Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, I will be asking a couple of questions asked by subscribers and followers from various social media. This is the 100 subscriber Q&A special, so I'll be answering a couple of questions that viewers have submitted. Feel free to submit more questions if you'd like. I will be doing more Q&A videos in the future, and if you'd like to make them happen faster, all you need to do is subscribe to the YouTube channel, and hopefully we'll hit another bigger milestone soon. So first off, the first question is, what is my favorite fun fact about astronomy? And I think my favorite fun astronomical fact is how unique eclipses are to the Earth. Our moon orbits the Earth pretty close to the path that the sun takes across the sky, and they regularly line up. That's one coincidence. It doesn't happen for every planet. Uranus is completely tilted on its side. So for example, if we find Uranus out here, we'll be able to see that eclipses are pretty close to impossible on Uranus. For the vast majority of Uranus's year, its equator doesn't line up with the sun at all. So we can see here, we're looking at Uranus from the direction of the sun. We're closer to the sun than Uranus, and we can see all of those moons around the side. So there's no way that they can get between Uranus and the sun and block it out. During the vernal and autumnal equinox on Uranus, right when the equator is pointing towards the sun, those moons could move in front of it. But scale matters as well. The Earth's moon is just the right size, and we're just the right distance from the sun that the moon can perfectly block out the sun. We block out the bright disk of the sun and still get to see its corona around the sides. For planets like Mars with moons that are very, very small, they'll never block out the sun. It will look more like a transit, a small black dot moving in front of the sun. Whereas for planets like Jupiter and for Saturn, although some of their moons are quite large, depending on how they're tilted and of course with different distances away from the sun, even if one of their moons blocked out the sun entirely, it wouldn't line up as perfectly as our moon blocking out the sun. So eclipses, although they're not necessarily unique to the Earth, covering the whole universe, there may be other planets going around other stars that get eclipses like us, but in our solar system, we're the only one with eclipses the way we get them. And there's a good chance that eclipses, like the ones the Earth sees, are rare in the universe as a whole. It is a lot of interesting coincidences. We're tilted just the right way. The moon is just the right size. For planets that are more tilted, and even planets that are less tilted than we are, those particular factors don't necessarily line up. That's got to be my favorite fun astronomical fact. But a fun fact about astronomy, about the topic, about the natural science, is just how broad it is and how useful amateurs are. So with a lot of sciences, especially when you look at them at their most broad, things like chemistry and biology, they cover a lot. Biology covers everything from bacteria and, well, viruses in some cases, all the way up to complicated things like us and whole biomes, the whole Amazon rainforest, the way all the animals interact. That's all in biology, you know, even if it's broken up into zoology or biochemistry. Of course, the sciences do bleed together a little bit with things like biochemistry, and of course astrobiology and astrochemistry. Astronomy gets some of those as well. We can study the sky by looking at it, observational astronomy, going out and finding these things to look at, charting their progress across the sky, and you can sit down and study the dynamics behind moons orbiting planets and discover things without ever looking at the sky in theoretical astronomy. It's such a broad subject, and there's so many ways that you can study it or contribute. For example, looking at this sky here with 2,500 or so stars visible, I can't keep track of exactly which ones are where, and if I closed my eyes and opened them again, and there was a new star over here, there's a good chance that I wouldn't even notice it. But some people can, and discovering transient events, supernovae, and even comets, it does get a lot of help from people going outside, looking at the sky, becoming familiar with it themselves, and discovering things like comets and supernovae as amateurs before any of the big observatories with telescopes and measuring things like light pollution. If you want to know if your sky is as clear and as beautiful as this countryside sky, but you can go and you can look, you can make comparisons, and you can contribute to the citizen science of astronomy. It is one of the best sciences to be an amateur. You can still discover things, you can still contribute, even if what you mostly do is just look at the sky as a hobby in your spare time. You can still make an impact. So that's probably my favorite fun fact about astronomy. Another question that I got was, what is something that people get wrong about the solar system? And I think there's two things that people get wrong about the solar system. One of them is pretty basic, and it is sort of a trick question. It is where the middle is. The middle of our solar system is not in the middle of our sun. The sun is huge, and of course the sun dominates the solar system in terms of the gravitational influence. Everything orbits around the sun, and really most other things don't have much of an effect on the sun. If the Earth disappeared, it wouldn't really change how the sun moves, whereas if Jupiter disappeared, it would. Jupiter and the sun really share a co-orbital point, and really this is true for the whole solar system. Because Jupiter is so massive, the center of gravity between Jupiter and the sun isn't directly in the middle of the sun. It's pulled a little bit to the side. So the sun does wobble around just a little bit as the planets orbit it, dragged by Jupiter. More than anything else, Jupiter is incredibly massive compared to everything else in the solar system. Even compared to Saturn, Jupiter leads the way by quite a lot. It is a lot more massive than Saturn is. Jupiter pulling the sun a little bit as it orbits around. That's not something we normally see in demonstrations of the solar system. If you see a video showing the planets orbiting around, and I believe even here, if I start to move through time, we won't really see the sun moving or wobbling. It doesn't really get shown, and it is pretty close to negligible. The center of the solar system is pretty much inside the sun or on the edge of the sun's photosphere. It's around the surface of the sun, but it's not exactly in the middle of the sun. So that does make the solar system, just a little bit different to what most people would expect. Another thing that many people mistake about the solar system is that our solar system is normal or average or typical in some way. The more we learn about other solar systems, the more we see this isn't necessarily the case. There does seem to be a great variation in solar systems, and a very big difference between what we're discovering in other solar systems and what we see in our own solar system. So taking a look at Jupiter there, its orbit is very close to circular. Taking a look at Saturn, it's a little bit off. We can see that the sun isn't in the center of this orbit drawn by Saturn, but it's still pretty close. And if we take a look at Venus, Venus has a very close to circular orbit. It's barely eccentric at all. The Earth, a little bit more eccentric. We can see that's a little bit more oval shaped, but again, not by much. When we look at other planets going around other stars, they're often very eccentric. They're often way more oval shaped than the orbits we see for the major planets. And even with smaller objects, things like Pluto and dwarf planets, comets have often very eccentric orbits, and Pluto, being a dwarf planet, being more of a minor body, its orbit can be and is a little bit more eccentric than the bigger planets. But this doesn't seem to be typical at all. Even having a group of big planets and a bunch of smaller planets doesn't really seem to be typical. We don't see that many big solar systems like ours with, 8 or 9 planets. And very often we don't see as much of a variety. Here's Pluto's orbit, and that should give us a better idea. We can see that that is very much not a circle, and it's definitely not centered on the sun. So Pluto's orbit is quite eccentric. While it was considered a planet, it was considered the most eccentric planet. In fact, if I can get all of the orbits to come up together, we should be able to compare that to Neptune. Well, it is a little bit tricky. There are a lot of orbits going on here. But Pluto's orbit passes inside the orbit of Neptune for part of its journey around the sun. That's how eccentric it is. Even though on average it is further from the sun than Neptune, its orbit is so squished, sometimes it is closer to the sun than the path that Neptune takes. So Pluto is a strange one. And we do generally see those strange or eccentric orbits in our solar system, at least, with those smaller things. But in other solar systems, even quite large planets can be quite eccentric. And the ones that aren't eccentric are usually tidally locked, stuck facing their sun. For a long time, people thought that Mercury was tidally locked, but it turns out that it's not. Mercury does in fact turn around, and of course we have a previous video on its strange path around the sun. So I'm going to bring us back to the Earth, but keeping my videos to a reasonably regular length. I won't get started on the next question, which is to do with eccentricity, but I will leave it for the next video. So it looks like we're going to have a two-part 100 subscriber Q&A special, with this first part answering the first couple of questions and the next part coming out on Thursday answering the rest. So if you asked a question and it wasn't answered here, it will be later this week. And if you would like to submit questions, you absolutely can. Right here on YouTube, through Queebean's content on Instagram, or at queebeanscontent.ie, where you can also read a little bit written about these answers. So I hope you enjoyed these answers, and I hope for the next set.